It's a boy Rohit, and today's topic is about magnetic field. So in magnetic field we will learn some important topics regarding on the magnetic field, the Amperian law, that is the most important thing, and then some another things like cyclotron and toroid, etc. So let's start this topic right ahead. So first topic is magnetic field due to a current wire. So the formula is given by mu naught upon 4 pi I cross dl upon r square. Now the value of mu naught is 4 pi into 10 to the power minus 7. That is why the 4 pi gets cancelled and the value remains 10 to the power minus 7. Now what is mu naught? That is the magnetic permeability of vacuum. Okay, now we know that A cross B equal to AB sin theta. So due to this I cross dl, the formula comes to be mu naught upon 4 pi I dl sin theta upon r square. Now the direction of magnetic field can be determined by doing the cross product by the right hand thumb rule, like I cross dl. Next, magnetic field due to a current carrying straight wire, that comes to be mu naught I upon 4 pi r cos alpha plus cos beta. Now one thing to remember, as I have told in the electrostatic video, that is the alpha and beta should be remembered very thoughtfully, because the common mistake that can be occur is that you consider these as alpha and beta and you write the formula of theta 1 and theta 2. So please note this carefully, that which angle I have taken and with what respect I have written this formula. So this angle is with the base one, that is alpha and beta. So the formula is mu naught I upon 4 pi r cos alpha plus cos beta. And by taking the theta 1 and theta 2, I have written the formula as mu naught I upon 4 pi r sin theta 1 plus sin theta 2. Next, B due to an infinite long wire. Now for infinite, this formula need not be remembered. I mean, you can remember it, but it's better to think this way, that since this is infinity, so taking this as theta 1 and theta 2, since we have taken this angle as theta 1 and this angle as theta 2, so it is meeting at infinity. So we can say that this angle is closely becoming to 90 degree. So we can say that theta 1 equal to 90 degree and theta 2 equal to what? 90 degree. So putting these two angle in the place of sin theta 1 plus sin theta 2, it comes to be mu naught I 2 upon 4 pi r square. So 2 and 4 gets cancelled and the remaining formula becomes what? Mu naught I upon 2 pi r. Next, B due to a semi-infinite wire. For a semi-infinite wire, as you can see, the base angle, that is the theta 1, is becoming 0 degree. Now considering this as theta 1, right? Because at first we were considering this as theta 1, but in this case I am considering this angle as theta 1 and the upward angle this as theta 2. So theta 1 becomes 0 degree and theta 2 becomes of 90 degree. So again, putting the value in the first formula, we get mu naught I upon 4 pi r. Next is magnetic field due to a circular arc. This is a pretty simple formula, that is mu naught I theta upon 4 pi r. Just add the theta with the semi-infinite wire formula. Just add theta. Theta is what? The angle of the circular arc. For circle, it should be 2 pi. For a semicircle, it should be pi. So according to the arc, the angle will vary. Next, magnetic field at the axis of a circular coil. In case of a circular coil in electrostatics, I have defined it very carefully, that by taking a small element dx, we first calculate its contribution of magnetic field in this particular position, and then we integrate it throughout the whole ring to get the entire formula of the ring. See, I have done this the same way. First I have taken the contribution, then I have taken the dB dash, that is dB cos theta. Next I have written the formula of cos theta. See here, that base upon hypotenuse, same. Then I have integrated the whole thing, and the last formula has come, that is the resultant formula has come to be mu naught I r square upon 2 r square plus x square whole 3 by 2. This formula is very important. Now there comes two cases, that is case 1 at x equal to 0, that is the center of the coil. So at the center of the coil B, that is mu naught I r square upon, so in case of x we are writing as x cube. Why? See, at the center and in this front formula if we put x equal to 0, then the whole 3 by 2 gets cancelled and it becomes r cube. That is why the answer comes to be mu naught I upon 2r. Okay, and then the next case comes to be at x greater than r, that is at a large distance. That means you can consider infinity. That is magnetic field due to a ring at infinite distance. So that thing can be considered as B equal to mu naught into 2 mu upon 4 pi x cube. Mu is what? Mu is the magnetic moment, and that is Ia. A is area. Next, the very important concept, that is the Ampere's law. All the formula I have derived in the previous section can be easily derived by using this law. Now what is this law? So Ampere's law states that the surface integral of magnetic field of a closed surface is equal to mu naught times the current enclosed by this closed surface. So this I net is only affected by the current enclosed by this surface, not by any current outside this loop. If the current is located here or here, it will not affect the I net. So by using this concept, we will find the magnetic field due to an infinite cylindrical thick wire. Now as we know that in the big cylinder there is a current of I. Now we will find the current inside this small surface of radius small r. So by using unitary method we calculate it as I r square upon r square. Next, by using the Ampere's law we find the formula as mu naught I r upon 2 pi capital R square. Smaller is the distance from the center and capital R is the radius of the whole cylinder. Next, if suppose the point is at outside, then we can consider the whole formula as the formula of the infinite long wire, because as you see the formula of that and this is the same. So the formula of the infinite long wire can be easily calculated within one step by using this Ampere's law, because see B into integral of dl equal to mu naught I. Integration of dl is 2 pi r, because that is the area in which the magnetic field is contained. Now if suppose the graph is told to given, that is for a point outside as well as inside, so the graph will be same as that of electric field. First it will be directly proportional to r, then it will be inversely proportional to r. Next, magnetic field due to a solenoid. Now this is the main picture of the solenoid. The magnetic field is concentrated in this fashion. Now in this scenario we have considered this picture. Now you can ask that why this picture, because when you will do the cross product you will closely observe that from one point the magnetic field is entering while from another point it is exiting out. So we have taken a Amperian loop. Now, how is that loop? The loop is considered somewhat of this fashion. The loop is considered somewhat of this fashion. That is the P, Q, R and S. Okay. Now we have found the integral of B dot dl partly. That is, at first from P to Q, then from Q to R, then from R to S. So partly we have done. So in the portion of P to Q, the contribution will be BL, because there is magnetic field and the angle between them is 0 degree. Because see, B dot dl, that means B dl cos theta, right? So as you can see, the angle here is 0 degree, that is why the contribution will be BL. Next, the contribution from R to Q will be 0, since theta equal to 90 degree. For which one? From Q to R and S to P. In both these cases the contribution will be 0, since the theta is 90 degree. And from S to R, now this portion is important. From S to R the contribution will also be 0. Why? Because as you can see carefully that for the whole Amperian loop the magnetic field is not present. It is present for some portion, but for some portion it is not present. So that is why we can tell that due to the absence of magnetic field, the contribution from S to R will be 0. Now as I have told earlier, the same thing has been written here. You see, from P to Q, contribution will be BL, from Q to R, from R to S, and from S to P, the 3 will be 0. I net will be NLI. N is what? Number of turns per unit length. Now by using the Ampere rule, we derive the formula as mu naught Ni. So the magnetic field in the solenoid will be mu naught Ni. And remember this is the magnetic field at the center of the loop. This is the magnetic field right at the center of the loop here. Now note, the portion Q to R and S to P had 0 contribution because magnetic field is perpendicular to dl, and the portion R to S was 0 because magnetic field was 0 outside the loop, as I have told, right? And then magnetic field at the end of the solenoid will be mu naught I upon 2. This is because the end is divided into 2 parts, so for each part the contribution will be of half and half. So that is why it comes to be mu naught I upon 2. Next, magnetic field due to a toroid. You can directly remember the formula, but it's better to remember this small derivation, because if suppose you forget the formula, this derivation will come in hand. So similarly, applying the formula of Ampere's law, B dot dl, it will be B dot 2 pi r into mu naught upon Ni. So B will be mu naught Ni upon 2 pi r. Now N by 2 pi r should be equal to small n. Why? Because small n is number of turns per unit length. So that is why the short formula comes to be mu naught Ni, as same as the solenoid. This comes as same to as of solenoid. Now B due to an infinite large sheet. So suppose there is an infinite large sheet of infinite length as well as of infinite breadth. Like suppose the sheet is of infinite from this side, and from all the side it is of infinite, like this, and this. So in this infinite sheet of charge, the contribution of the magnetic field will be, again we will do the same partly, from A to B, then from B to C, then from C to D, and from D to A. Now here the magnetic field is present in the entire part since it is infinite. So the magnetic field is present everywhere throughout the loop. That is why here the contribution of A to B and C to D will be B to L, but the contribution from D to A and B to C will be 0 as usual, because the angle between them is 90 degree. So by doing the whole integration, we see the result is 2BL. Next, similarly applying the Ampere's law, it comes to be mu naught I upon 2. What? Mu naught I upon 2. Now if you look carefully, all these formula have a close relation. You have to study this and you can find this relation within yourself, how to remember it fast, right? Next is force between parallel wires. So two parallel wire is given, the distance between them is d and the length is given as L. So the force between them can be written as mu naught I1 into I2 into L upon 2 pi d. So this formula needs to be remembered because by using this formula direct questions in mains have come and as well as in advance. So this formula is very important of force, that is mu naught I1 into I2 into L upon 2 pi d. I1 is the current of the first wire, I2 is the current of the second wire, L is the length and d is the distance between them. Now here the radius is given of what? Cyclotron. Cyclotron. Now how a cyclotron looks? A cyclotron looks like this. So what does it do? It normally accelerates a charged particle by using both electric field as well as magnetic field. Now the magnetic field is outside, right outside. The electric field is inside these Ds. So this structure, this D-shaped structure are called Ds in fact. So in this Ds, electric field is concentrated and the charged particle is started from this. By using the magnetic field, a circular motion is created and this in turn rotates and rotates, passing through the electric field repeatedly and giving a greater acceleration, and at last it strikes out from the cyclotron to give it a high acceleration. Now this is sometimes used to heat the metal surfaces to cause photoelectric emissions, and there are many other uses of cyclotron, but this is one use, that is to do photoelectric emission. So due to the magnetic field the motion created, so for that the force is QVB sin 90 degree. So these formula can be written by using the magnetic force. I will talk about you later. The formula mainly is F equal to Q V cross B. So from there, that is QVB sin 90 degree, because the angle between V and B is 90 degree in this case, and the mv square upon r is due to the centripetal force. Now as the charge is rotating, due to the circular motion, a centripetal force is faced by the charge right at the center. So that force is mv square upon r. So from that we derive the formula of r as mv upon qb. Now the time period, we know the formula of time period is what? Time period equals to 2 pi upon omega. Now omega can be written as v upon r, that is velocity upon radius. So in the same fashion we have written the formula of time period to be 2 pi r upon v. Now here now we have written the formula of r from the first thing, that is mv upon qb. So vv gets cancelled. The in fact formula comes to be 2 pi m upon qb. Now the kinetic energy of the cyclotron, that is half mv square. Now see, radius we have got that mv upon qb. So from there we have got the velocity as qvr upon m. Just putting the value of v in the formula, we have got half into q square b square into r square upon m. So that is the kinetic energy of the cyclotron. So guys, that is it for the magnetic field. In the next topic we will cover the magnetic force, and then the whole this magnetic field and force, the whole topic will be completed. If you like this video, make sure to subscribe, make sure to hit the like button, and make sure to comment as well, and please don't forget to share. Thank you guys, have a nice day.